First, we will be solving for the force of friction. The force of friction is equal to the normal force times mu, which helps define the force of friction itself. For us, the normal force is equal to the amount of learning within a given class period. The units for this would be minutes. The force of friction itself is En, giving us the units for mu being Wahlbergs.
So here, a Wahlberg is defined as distractions divided by relativity of distractions, or how distracting they actually are. And here, mu is given by 10 distractions from En by about 16.67 distractiveness of those distractions, meaning that mu now equals 0.6. And in the case of a physics class, our normal class period is 80 minutes long, meaning our normal force is 80 minutes. And if the force of friction equals mu times the normal force, that is 80 minutes times 0.6. And that gives us 48 minutes lost due to En's distractions.
And I met you in the summer.
What the hell is this shit? What are you playing this, Loyd? Just get over it.
Yeah.
Get over it. What are you doing?
So annoying.
What? You just play. You need a better music selection. All right, whatever.
Today we're going to be talking about Coulomb's law, and remember, this K is not the same K in our spring equation. Okay, this is a different K. This is 8.99 times 10 to the 9th newtons times meters squared divided by Coulomb squared. So that's on the paper that I passed you guys out. So if you guys want to make sure you reference that and see where that is. Ian, are you serious? Get out. Go. Leave my classroom.
We will be solving for energy. This is mgh plus half mv squared and then repeated. For us, G is equal to the units of granola eaten by Miss Loyd. H is then equal to Miss Loyd's level of happiness. V is then equal to her voltage of SAS for the day. If she eats 5 granola bars, giving her 500 Gs, and then is at a 6 level of happiness, plus half of a voltage of SAS of 8 volts squared, that would give us a high level of energy. Meanwhile, a low level of energy would be if she ate 1 granola bar, giving her 100 units of granola with only a level 2 happiness, plus half of 16 volts squared of SAS. This gives us 3,000 plus 32 for a high voltage, giving us a total of 3,032 Doxmans. And for the low level, 200 plus 128, giving us 328 Doxmans.
So here we have an inclined plane with a 30-degree angle because there are 30 days in a month. We have a force of gravity and a normal force, where the force of gravity is a child's confidence level, and the normal force is summer because it's what holds us up. And in the x direction of the force of gravity is stress, the y direction is curriculum, all of which bring us down. So here, our net force equation can be modeled as follows. The net force equals the sine of 30 degrees times mass times gravity minus mu cosine of 30 degrees times mass times gravity. And this is the force of gravity in the x direction minus friction. So here we can substitute 0.5 in for sine of 30 degrees and 0.866 in for cosine of 30 degrees. And we bring down the mass times gravity on each side. And we set that equal to ma as net force equals mass times acceleration. And we have masses in every single term, so those cancel out. And now we're left with our acceleration equation. And we substitute 0.6 Wahlbergs in for mu.
Finally, we have an equation of a.5g, which is equal to 10, as found in a recent study, minus 0.6 Walls times 0.866 times 10. This gives us 5 minus 5.1 equals a, giving us a final answer of a equals -1 confidence lost per day. Overall, that gives us -3 confidence per month lost.
Oh, Kieran, what's the matter?
Oh, 0 points.
It's so sad.
That's me.
What do I always say?
I don't know.
Stress is a choice. Happiness is a choice. Choose wisely. You can do this. You're smart enough. Stress is a choice.